Humanity produces over 1 billion waste tires every single year.
Left alone, they become a permanent environmental scar.
But in this facility, they are the raw material for a new beginning. Specialized heavy lifters begin the extraction process. Sorting the usable rubber from the completely degraded waste. From the dump site, the journey to the processing plant begins.
Entering the recycling zone, strictly controlled and monitored.
Every kilogram of rubber is accounted for before processing.
The raw harvest is delivered to the sorting bay. Skilled inspectors ensure no foreign metal damages the shredders. Past inspection. Now, the destruction begins. Before shredding, the steel skeleton inside the tire must be addressed.
These wires are too tough for even the strongest shredders.
The steel is salvaged separately. Nothing here goes to waste.
Oversized tires are sliced into manageable chunks. Hydraulic pressure severs the strongest bonds in seconds.
All streams merge into the main artery of the plant.
Systems are green. The main reactor is hungry.
They approach the heart of the facility. The primary shredder. The most powerful machine in the building.
It generates enough torque to crush a small car.
Phase 1 of destruction is complete.
The high-torque blades shear the tires into rough 6-inch strips.
It's a battle of physics. Torque versus toughness. The tires are now reduced to rough shreds, or TDF.
But the material is still contaminated with sharp, liberated wire. A powerful electromagnet hovers above the stream. It snatches the liberated steel wire right out of the flow. This scrap steel is recycled separately for smelters.
Sizing is critical. Only the right sized chips can pass.
Anything too big is sent back to the shredder for another round. The rough shredding is done. Now for the fine work. We move from brute force to high-speed precision.
Here, the rubber will be pulverized into crumbs.
Inside the chamber, the chips are slashed again and again. They remain trapped in the loop until they are small enough to pass.
But the rubber is not pure. it is contaminated with synthetic textiles. To clean it, we use the laws of aerodynamics. Heavy rubber falls, light fiber flies. Simple physics.
The vacuum system extracts 99% of the nylon fiber.
This textile waste is often used for insulation or fuel.
A secondary magnet catches the microwires the first one missed. Clean, wire-free, fiber-free rubber granules. But for some clients, this size is still too coarse. The material is stored here, ready for the final transformation. Phase 4 is complete. Now, we make dust. To create high-value rubber powder, we must grind down to the micron level. The granules are fed into the gap between two serrated metal discs. Friction generates immense heat as the rubber is torn apart. The result is a powder fine enough to pass through a sieve.
Precision is everything. Consistency must be guaranteed.
Coarse particles are sent back for a second pass.
This is 80 mesh rubber powder, smooth as flour.
Quality control verifies the geometry of the particles.
Surface area is key for bonding in new asphalt or molding. The transformation from trash to raw material is complete. To create new products, the rubber powder must be bound together. Pigments are introduced to customize the final look. The mixture is agitated until every granule is coated.
Preparation is vital so the rubber doesn't stick to the steel.
The mold is filled with an exact weight of material. Even distribution ensures the tile has uniform density.
Heat and pressure are the catalysts for rebirth.
Tons of pressure cure the binder and lock the shape. Under heat, the granules fuse into a single solid block. For large-scale flooring, individual molds are too slow. We create density first. A solid log of compressed rubber. Precision blades peel the log into a continuous sheet. This allows for rolls of rubber hundreds of feet long.
Automated dozers add color flex for commercial gym aesthetics.
Calendaring rollers fuse the color permanently into the base. Automated cutters size the rolls without stopping the line.
The winding machine creates a perfectly tight package.
Heavy lifting is hazardous for humans, so robots take over. secured and sealed for global shipping. But before shipping, we need one final touch.
For interlocking gym mats, we need surgical precision.
Using water pressurized to 60,000 psi, we cut without heat.
No melting, no burning. Just a perfectly clean edge.
The waste is sent back to the shredder. Zero waste loop.
The fit must be tight enough to hold water.
Heavier products, like traffic speed bumps, require hardware.
Reinforced mounting points ensure they stay on the road. Reflectors are pressed in to catch headlight beams. Branding is the final mark of quality assurance.
Phase 8 complete. The rubber has found its new form.
Before shipping, the science must be verified.
We extract core samples from every production batch.
Density determines durability. It must be exact.
We test the breaking point. How much force can it take? It exceeds industry standards by 40%.
Impact absorption is critical for gym safety.
The energy is absorbed, protecting the concrete below.
Simulating years of heavy foot traffic in minutes.
Even when wet, the grip must remain absolute. From desert heat to Arctic cold, it cannot crack.
The chemical bonds hold strong in any environment.
Phase 9 passed. The product is ready for the world.
The production loop is closed. The pallets are full. Sealed against moisture and dust for the long journey. Every pallet is digitally tracked in the global inventory.
Logistics takes over. The warehouse is waiting.
Thousands of tons of diverted waste. Now, valuable inventory.
Stored and ready for deployment to construction sites worldwide. Orders come in from gyms, playgrounds, and road crews. We fill the container to capacity. What was once trash is now a global commodity, leaving the facility to build the infrastructure of tomorrow.
And this is how modern factories produce recycled rubber from start to finish.
Join us next time for another industrial deep dive.